A body of mass 500 gram collides against a wall with a velocity of 10 meter per second and rebounds with same speed. Okay, 10 meter per second. We have to calculate change in momentum. What is change in momentum? Change in momentum means final momentum minus initial momentum. Okay. So final momentum is mass into final velocity minus initial momentum is mass into initial velocity, or I can write it as m into v minus u. Okay. So initially, say you take this direction as minus x. So this is minus 10 meter per second. This is plus 10 meter per second. Okay. Mass is 500 gram, 0.5 kg. Into final velocity is this. Final velocity is 10 meter per second. Minus initial velocity is minus 10 meter per second. 10 minus of minus 10 will be plus 20. So that is equal to 0.5 into 20. 0.5 into 20 will be 10 kg meter per second. We'll move on to next question. Question number 49. A shell of mass 60 kg is fired from a cannon at a velocity of 500 meter per second. If the mass of the cannon is 1500 kg, then its recoil velocity is. This question is based on law of conservation of linear momentum. Law of conservation of linear momentum. Okay. So initial momentum of the system should be equal to final momentum of the system. So this is the concept. Okay. Mass of the shell into velocity of the shell is equal to mass of the cannon into velocity of the cannon. So then its recoil velocity is, means velocity of the cannon we have to find out. Velocity of the cannon is equal to mass of the shell into velocity of the shell divided by mass of the cannon. What is mass of the shell? Mass of the shell is 60 kg into velocity of the shell is 500 meter per second. 500 divided by mass of the cannon is 1500 kg. 1500. So 500 goes 3 times. 60 by 3 is 20 meter per second. So therefore the recoil velocity of the cannon is 20 meter per second. Next question. 3 books X, Y and Z rest on a table. The weight of each book is as indicated. Weight of X is 4 Newton, weight of Y is 5 Newton, weight of Z is 10 Newton. The net force acting on the book Y is, what is the net force acting on the book Y? That we have to calculate. First what you have to see is very important thing. The books are at rest. Okay, if the particle is at rest, then the net force acting on the particle is 0. Since book Y is at rest, net force acting on book Y will be equal to 0. So this is a conceptual question. For the net force acting on book Y is equal to 0, since it is at rest. When the body is at rest, downward forces acting on the body will be equal to upward forces acting on the body, so that net force acting on the body is equal to 0. Next, question number 51. A body A is at rest. Okay, rest. A body B is moving with uniform velocity of 40 meter per second. Body B is moving with uniform velocity of 40 meter per second. So velocity of body A initially is 0 meter per second. The force F1 acts on A and F2 acts on B. Force F2 acts on B for 10 seconds. The velocity of A and B now are 40 meter per second and 80 meter per second respectively. Velocity of A is 40 meter per second. Velocity of body B is 80 meter per second. if A and B are of equal mass, then what is the relation between the forces? What is the relation between F1 and F2? How to solve this? We know that F is equal to m into A. What does it mean? It means F is directly proportional to acceleration. So therefore, as masses are constants, mass of A and B are equal, they have given. Okay. Therefore, we can write F1 divided by F2, F1 divided by F2 is equal to A1 divided by A2. Okay. So what is A1? Acceleration of the first ball. What is acceleration? Final velocity, okay, 40, minus initial velocity, 0, divided by time taken. What is time taken? 10 seconds. Divided by acceleration of the second body. What is acceleration of the second body? Final velocity, 80, minus initial velocity, 40, divided by 10. So what happens? This 10 here and this 10 here gets cancelled. So F1 by F2 is equal to 40 divided by 40. So that is equal to 1. So what does it mean? F1 is equal to F2. F1 is equal to F2. A heavy uniform chain lies on a horizontal tabletop. If the coefficient of friction of the chain and the table surface is 0.25, then the maximum fraction of the length of the chain that can hang over the edge of the table is, okay. So there is a table which is placed on a horizontal surface, and there is a chain. Some small portion of the chain is hanging over the edge of the table. So length of the hanging portion, let it be L. Total length of the chain, let it be capital L. So the length of the chain which is on the table is L minus L. Total length of the chain is L. Length of the hanging portion is small letter L. Length of the chain which is on the table surface is capital L minus small l. Okay. Now the question is the maximum fraction of length of chain that can hang over the edge of the table. Okay. Maximum fraction of length. Now what we have to observe here is this portion of the chain is trying to pull the chain downwards. Okay. This portion of the chain is opposing it, because here between the chain and the table there is a frictional force which is not allowing the chain to fall down. So frictional force between the chain and table balances weight of the hanging portion, mass of the hanging portion into G. Now here we know that since it is a uniform chain, okay, length is directly proportional to mass. Okay, so therefore what we can do, frictional force is equal to mu mg is equal to mass of the hanging portion into G. Now what is this m? Which mass of the chain is responsible for friction? Mass of the chain which is on the table. Okay, so mass of the chain which is on the table, okay, lying on the table, is proportional to length of the chain lying on the tabletop, that is L minus L into G, is equal to mass of the hanging portion is proportional to length of the hanging portion. Okay. What happens? G and G gets cancelled. Mu will be equal to L divided by L minus L. Okay. So this implies what I need is fraction of length of the chain that can hang over the edge. Means I need L divided by capital L. Okay, fraction of length I need. Okay, so if I substitute the value of mu is equal to 0.25, okay, into L minus L is equal to small letter L. 0.25 into capital letter L minus 0.25 into small letter L is equal to L. So what happens? I'll just create some space to solve here. Okay, so what happens? 0.25 into capital L is equal to 1.25 into small letter L. Now I'll do the remaining simplification here. What happens? 0.25, that is 0.25 divided by 1.25 divided by 1.25 equal to small letter L divided by capital letter L. So what happens? So this is 1 by 5. 1 by 5 is equal to L by L. What is 1 by 5? 1 by 5 is 0.2. 1 by 5 is 0.2. What does it mean? 20% of the length of the chain is hanging over the edge of the table. Next, a block of mass 2 kg is placed on the floor. Okay, a block of mass 2 kg is placed on the floor. The coefficient of static friction is 0.4. Okay, mu is 0.4. If a force of 2.8 Newton is applied on the block, parallel to the floor, the force of friction between the block and the floor is, okay, force of friction between the block and the floor. Okay. So what is the maximum value of static friction? That I will find out. Maximum value of static friction is equal to mu s into mg. Okay, so that is equal to mu s is 0.4, okay, into mass is 2 kg into g is 10. Okay, 10 into 0.4 is 4. 4. So 4 into 2 is 8. Okay, maximum value of static friction is 8 Newton. What does it mean? If the applied force is less than 8 Newton, then the block will not move. Correct now? If this block has to move, applied force has to be greater than maximum value of static friction. Okay, till then frictional force is directly proportional to applied force. Means as the frictional force increases, as the applied force increases, frictional force also increases till the maximum value of static friction. Frictional force is directly proportional to applied force. Therefore, here applied force is 2.8 Newton. Frictional force will be equal to applied force. So therefore, the answer is 2.8 Newton itself. It's a very tricky question. Okay. Now, since we have applied 2.8 Newton, which is unable to move this block. Okay, the block is not moving forward because the force that we have applied is less than 8 Newton. Correct now? Now the block is not moving forward or backward. Therefore, some frictional force should be there developed in the opposite direction, which has a magnitude is equal to 2.8 Newton. Okay. Next, question number 54. A cricket player stops a cricket ball of mass 150 gram moving at a velocity 50 meter per second. If the ball is caught in 0.15 seconds, the force of the impact on the palm is, since the force experienced here is impulsive force, okay, force experienced is impulsive force. So what is impulse? Impulse equal to force divided by time, or force equal to, we have from second law, rate of change of momentum, change in momentum divided by time taken. Force equal to change in momentum divided by time taken. What is change in momentum? Final momentum minus initial momentum divided by time taken. Okay. So here what is final velocity? Final velocity is 0. Okay. And initial velocity is 50 meter per second. Final velocity is 0. Initial velocity is 50 meter per second. So therefore, what happens? This becomes 0, right? So F, change in momentum, is simply mu divided by t. Okay. So what is m? M is 150 gram. Okay, 150 into 10 to the power minus 3 into u. What is u? U is 50. 50 divided by 0.15. So what happens? 150 into 10 to the power minus 3 means 0.15 into 50 divided by 0.15. So 0.15 and 0.15 gets cancelled. So F is equal to 50 Newton. Force of the impact on the palm is 50 Newton.